when we observe Venus at visible wavelengths, all we can see is a nearly featureless white cloud deck. Ground-based spectra, later supplemented by data from space probes to Venus, reveal that the clouds are made of sulfuric acid, which is H2SO4, of course. H2SO4, sulfuric acid. The sidereal rotation period of Venus, like that of Mercury, can be determined by radar astronomy. Venus turns out to be the slowest rotator of all the planets, with a sidereal rotation period of 243 days. Excusez-moi? Venus turns out to be the slowest rotator of all the planets, with a sidereal rotation period of 243 days? The rotation is not only slow, it is also retrograde. That is, if we looked at the solar system from above the Earth's North Pole, we would see Venus orbiting in a counterclockwise direction, the same as the other planets, but rotating in a clockwise direction. We would see Venus orbiting in a counterclockwise direction, the same as the other planets, but rotating in a clockwise direction. No! Probably as a consequence of its slow rotation, Venus does not have a detectable magnetic field. I did not know this. Because the orbital angular momentum and the rotational angular momentum of Venus are in opposite directions, the sidereal orbital period p rotation and the solar day p sol are related by the equation 1 over p rotation is equal to 1 over p sol minus 1 over p orb, where p orb is 225 days, is the orbital period of Venus. Thus, p sol is 117 days, 117. The surface temperature of Venus is high. Baji, let her be. It's her time now.
Shona Suchi. Look at Suchi. Little baby doll. Little Suchi baby. Your little baby. Oh, look at Sachi's face. Go to Shona. Go to Shona. Go to Shona. Shona. The baby. Small baby.
Small baby. The surface temperature of Venus is high. 740 kelvins. T equals 740 kelvins. Hot enough to melt tin, lead, and zinc. Despite the long solar day on Venus, the surface temperature is nearly uniform over the entire planet. This is because the circulation patterns in the thick atmosphere are highly effective at carrying hot air from the daytime side of Venus to the nighttime side, smoothing out the temperature differences. This is because the circulation patterns in the thick atmosphere are highly effective at... It's a thick atmosphere, so the circulation patterns are very effective at carrying the hot air from the daytime side of Venus to the nighttime side of Venus. Oh, because you're sick. Oh no. The high temperatures at the surface of Venus is a result of the greenhouse effect. As discussed before, we talked about the greenhouse effect gases, or the greenhouse gases, the other day on Earth. The sulfuric acid clouds of Venus reflect about 75% of the light that strikes them.